Alright, in this problem we're going to solve for the freezing point if we dissolve 100 grams of magnesium chloride in 100 grams of water. So the first thing that we're going to need to do is know which equation we're going to use. We're going to use the change in the freezing temperature equation. Which is delta T is equal to I times Kf times molality. Now, we need to solve for molality first, so let's go ahead and solve for our moles. We know that we have 100 grams of MgCl2. The molar mass of MgCl2 is 95.21 grams per mole. So this gives us about 1.05 moles. Now we're going to need molality, so 100 grams of water divided by 1,000 grams per kilogram is essentially 0.1 kilogram. So our molality will be 1.05 over 0.1. Or in other words, 10.5. Okay, so that's our molality. So now that we have our molality, if we look at the equation, we can plug in what we know. The I in the equation is the Van Hoff factor, and according to this equation it's going to be 3 because we're going to get 1 magnesium and 2 chloride ions from this. The value for Kf for water is 1.86 degrees Celsius kilograms per mole. That's a constant. That's for water, and it doesn't change as long as you're talking about freezing point. And we multiply this by our newfound molality, 10.5 moles over kilograms. So now we just run the numbers. So what this tells us is that the change in the temperature, freezing temperature of the solution is 58.6 degrees. Remember that this is the change to water's freezing temperature, and so to find the actual freezing temperature we have to subtract this from 0, which means the value is going to be negative 58.6 degrees. And that's how much, or that's what the new freezing point is going to be if we dissolved 100 grams of magnesium chloride in 100 grams of water.